Welcome back to the deep dive. We're going to keep going with objections overruled. And this chapter, we're tackling one of the biggest objections to faith. You know, that whole evolution is the only explanation for like where we came from thing. Look, I'm not here to deny that evolution is a powerful theory. It explains a lot about the natural world, right? But is it the whole story? That's what we're going to dig into today. But here's the thing. As convincing as Darwin's theory is, it does face some challenges. And one of the biggest is from the fossil record, specifically something called the Cambrian explosion. And this is where things get really interesting. The Cambrian explosion is this huge burst of complex life forms that appeared in the fossil record like 540 million years ago. It's like life went from 0 to 60 in a blink. And here's the problem. If evolution is this slow, gradual process, where are all the in between stages? They're just not there. It's like they just showed up ready to go. Scientists have been trying to figure this out for years. You know, it definitely changes the traditional understanding of evolution. It might mean the process is more complex, a lot faster than we thought. And speaking of missing pieces, let's talk about another challenge, the missing link. This is all about the search for the fossil that connects AIDS to humans. We've got fossils of early hominins. Yeah, but the exact lineage, the clear connection, well, that's still fuzzy. And the missing link isn't just about one fossil. It's about understanding the whole series of changes that led to us to Homo sapiens. It's like a puzzle with a big hole right in the middle. And Darwin's theory has more problems. It struggles to explain the link between apes and humans. But it also has trouble with the most basic question. How did life begin? Darwin's theory is all about how life changes over time, how it evolves, but it doesn't say how that initial spark of life happened. How did we go from non-living matter to living organisms? That's a big mystery. One famous attempt to solve this was the Miller-Urey experiment. They tried to recreate early Earth conditions, you know, that primordial soup idea. And you know what? They actually made some of the building blocks of life like amino acids. Pretty amazing, right? But even with that experiment, there's still this huge question. How did those basic building blocks become a living organism? Even simple life forms are incredibly complex. And that jump from non-life to life, well, science hasn't quite figured that out. The Cambrian explosion does kind of mess with that slow and gradual evolution idea, but it doesn't mean we throw out evolution altogether. It just makes us think about maybe some other possibilities. What if instead of those little by little changes Darwin talked about, there were, I don't know, like periods of really fast genetic change, like bursts of new stuff happening, or maybe something in the environment change, and that's what caused all this crazy diversification of life. It's not about did evolution happen, it's more like how did it happen? And that how makes it really interesting. It's like we're putting together this huge puzzle. And the Cambrian explosion is this big, crazy, colorful section we're still trying to figure out. Like the universe threw us a curveball, and now we have to figure out the rules of the game. And you're right, it's not about denying evolution, it's about digging deeper. One theory is called punctuated equilibria, and it says that evolution happens in like fits and starts with long periods of nothing much happening, and then bam, these really short bursts of change. It could explain why we see these new species in the fossil record, like in the Cambrian explosion, without all those transitions Darwin talked about. Those changes could happen so fast that they don't leave much of a trace in the fossils. It's like trying to take a picture of lightning. You might see before and after, but can't really see the lightning itself. And that's why the Cambrian explosion is so hard to explain with the traditional view of evolution. It makes us think differently, consider things beyond just those slow little mutations. And there's more research that's helping us understand this fast change. There's EVO, which is all about these special developmental genes. They're like the blueprints for how bodies are built. And even little changes in these genes can have huge impacts on evolution. Think about a blueprint for a house, then you change it a little bit. Speaking of puzzles, that brings us back to the biggest one, the origin of life. We talked about the Miller-Urey experiment and how they made some of the building blocks of life, but there's still a big gap. How do those pieces go from just floating around to becoming a living thing? Miller-Urey was groundbreaking because it showed that the ingredients for life could exist on early Earth. But how they became a cell, that's still a mystery. One idea is that RNA, which is simpler than DNA, was important in early life. RNA can hold genetic information and do things in chemical reactions. So it could have been like a proto-life molecule. So RNA was like a simpler version of DNA that could do two things at once: carry genetic information and make chemical reactions happen, like a multi-tool. That's cool. It is. And there's also research looking at hydrothermal vents, those underwater geysers that shoot out chemicals from the earth. They have energy and nutrients. Some scientists think they could have been where the first life started. So instead of Darwin's little pond, life might have started in these crazy deep sea vents, like a test kitchen for life where only the toughest organisms could survive. But even with that filter, the idea that life happened purely by chance, that it became as complex as we are today, it's hard to believe. It's like winning the lottery over and over. I get it. And that's why many people don't think is the only answer. They see how ordered and designed nature is and think there must be something more, some intelligence behind it all. And that's totally okay to think. Science tries to explain how things work, but it doesn't necessarily say there isn't a reason, a deeper meaning. That's where science and faith, reason and belief come together. It's like two languages trying to explain the same thing, right? Science looks at the details of how things work. It gives us this incredible picture of the universe. But faith asks the bigger questions. Why is there something instead of nothing? Why are we here? What's our purpose? It looks for meaning beyond the physical world, and both science and faith can help us understand who we are and how we fit into the universe. They make us think and question and appreciate the beauty and mystery of it all. It's like science gives us the blueprint of the universe, and faith helps us understand who made it. They work together. And in the end, whether evolution is the only explanation for humans is a philosophical question as much as a scientific one. Science can show us how evolution works, but it can't say for sure if there's something more going on, some ultimate purpose. It's not about rejecting science, but realizing there might be things beyond what science can explain. For a long time, I thought I had to choose between science and faith, like they were separate. But now, looking at these big questions, I'm starting to think maybe they're both pointing to the same truth, just in different ways. Science is awesome at explaining how things work. It gives us this understanding of the natural world, but faith asks why.